There is a limitation on the graphical method. Since graphical method only solves two variable problem, then we have to find the other way when there are more variables. Like we have a method known as simplex method. It can solve two variables or more variables are there in a problem, it can solve. So this method uses iteration method. Number of iterations are made and finally we will arrive at a solution where we will get the variables, values of variables as zeros or minus values, then we will stop it at that. It may take 2 iterations or 3 iterations or 4 iterations, but till that point of time we have to ensure that we have to keep on making those iterations till we get those values, which indicates that there will not be any value addition or positive values. It will result in positive value of a solution. To that extent we will do those kind of iterations. That is the purpose of doing the multiple iterations in simplex method.
We will do a problem on simplex method. So this simplex method is an iteration method. We will see how we are going to do this. So a company produces 2 products tetra and tetra. Each unit of tetra requires one machine hour and 2 man-hours. Tetra requires requires 2 machine hours and 1 man hour. Man hour. The available machine hours are 720, while that of man hours are 780. Tetra will not be sold more than 320 units. Profit on tetra is rupees 6 per unit, and on tetra rupees 4 per unit. Use simplex method to solve LPP. So before solving the problem through simplex method, we need to formulate LPP. So we'll see formulation of LPP. Formulation of LPP or linear programming problem. So there are two products. Let us assume that x1 and x2 be the number of units of tetra and tetra being produced to maximize profit. So then our objective function. The objective function is maximize Z. Maximize Z is equal to 6x1 plus 4x2. This is profit. So we want to maximize profit, where 6 rupees is on tetra per unit and 4 rupees on. And this is subject to certain constraints. Subject to the constraints. Subject to the constraints. What is that constraint? x1 plus 2x2 is less than or equal to 720. That means there are only 720 machine hours are available. So we call this as machine hours constraint. Similarly, we have man hours constraint. 2x1 plus x2 is less than or equal to 780. So this is man hours constraint. That means there are only these many man hours are available. So we have another constraint, that is x1 should be less than or equal to 320 units. This is a market demand constraint. So more than 320 units cannot be sold. So not more than those number of units can be produced. And now, as usually, we have to write this constraint where x1 and x2 are non-negativity restrictions. Non-negativity restrictions. What does that mean is x1 and x2 cannot assume negative values. That means x1 and x2 either they can be 0 or they should be more than 0. So there cannot be any negative value. Either we will produce tetra or we will not produce. Even if it not produce, that will be 0. Now for solving the problem, we will convert those constraints into equalities. Converting constraints into equalities or equations. So to convert them into equalities, we will introduce some variable for each of the equation as S1, S2 and S3, which means they are surplus variables. And in the second equation we will use S2, which is also a surplus variable. And similarly in the third equation we will use an equation, a surplus variable S3. So these are surplus variables. What actually the surplus variables indicate is, for example, we have a log of wood from which we will produce certain furniture. Whatever that is remaining, which is not sufficient to produce any of the articles, will be thrown out as a wastage or scrap. So that is known as surplus, which we could not exactly use it, or the entire thing could be used it. So that is the scrap or surplus which could not be usefully engaged, or which can be used to the full extent. So we call them as surplus variables. Here in those equations, this is all x1, x2, s1, s2, s3, they should be equal to 0 or greater than 0, but not negative under any circumstances.